What's up YouTube? This is VeerMath&More, and today we are going to be doing a video over learning how to deal with limits and just applying different strategies and techniques to solve limits. Let's get straight into it. So in our first problem here, we are going to be finding the limit as x approaches pi over 4 for tangent x. And as we all know, tangent x is a trig function, and but the way we solve this is that we want to substitute the value that x is approaching. So here it is pi over 4. So I always like to write down my limit once more, just so that I can understand where I'm starting from. And I just said we just substitute x approaching pi over 4. So that would just be tangent pi over 4. And tangent pi over 4 is, as you all know, is 1. And why? Well, that's because tangent pi over 4 is equal to sine pi over 4 divided by cosine of pi over 4. This is root 2 over 2. This also is root 2 over 2. The same number divided by itself is 1. Therefore, our first answer is a simple 1. So in our second problem, we are doing just finding the limit as x approaches 3 for the function x cubed minus 2x cubed plus 2x squared minus 9x minus 18 divided by x minus 3. So the way to solve this is that we cannot apply simple substitution, as that would result in an indeterminate form. So our indeterminate form obviously is just 0 over 0, infinity over 0, really like anything like that. Infinity over infinity, etc. Right? That's your indeterminate form. So we don't want that, so what we do is we're going to want to just substitute. We're going to want to factor our top part so that the x minus 3 can be cancelled out. So once again, you write down your limit. That way you don't have to keep looking back at the problem, and it just helps me visualize it once more time. So we have our limit written down, and the top part, you have multiple ways which you can probably do it, but the way I do it is that you can just do group factoring, and you see that x squared can be factored out of the first one, so it becomes like that. And then out of the second one, you can take away, like that. So, and then on the second one, you can take out minus 9, so it just becomes x squared multiplied by x plus 2 minus 9 multiplied by x plus 2, all divided by x minus 3. And a simple habit which you can lose points for is to forget your limit thing. So always have your limit there. And then you want to simplify this. You put these two together, and these two obviously has common factor. So you're just left with x plus 2, x squared minus 9 divided by x minus 3, limit as x approaches 3. Now what we want to do is we have to realize with your algebra skills that x squared minus 9 is just a difference of squares of x plus 3 and x minus 3. So then we can write our answer, our limit now, as x plus 2 times x plus 3, x minus 3, all divided by x minus 3. And then we can cancel out the x minus 3 because it's multiplication. Well, technically it's division, but there's no addition or subtraction. And you're just left with limit x approaches 3 of x plus 2 and times x plus 3. And you plug in your 3, you get 5 times 9, so 45 is our final answer. So in our third problem here, we are trying to find the limit as s approaches 9 for 9 minus s all divided by the square root of s plus 3. And the way we're going to solve this is we're going to use a method called multiplying by the conjugate. This allows us to eliminate the square root and evaluate for a function that isn't in indeterminate form. And by the way, indeterminate form obviously is your 0 over 0, infinity over infinity, and infinity over 0, and etc. We do not want that. So, in order to solve this, like I said, you always write down your limit, regardless if the problem is there or if it's not. That's just how you would do it for me. Then, our first step is to multiply by the conjugate. So our square root here, or our denominator is root s minus 3. Now, as I was going to say, our conjugate of that would be root s plus 3. Basically, a conjugate is just to create a difference of squares. So you want to multiply that whole thing by root s plus 3. And to keep it as 1, because we cannot just be randomly multiplying anything we want to do, otherwise that wouldn't make sense. You multiply root s plus 3 on the numerator and denominator to keep it equal. And now what does this do? This allows us to make this bottom part equal to root s times root s, which is s, and negative 3 times positive 3, which is negative 9. Then, on the top part, I would recommend in these type of problems where you're going to use your conjugate method to not, multiply this out or distribute it, but just to keep it as it is. So you're going to leave it as 9 minus s times root s plus 3. And if you cannot already see by now, we have a pattern of n minus s and s minus 9. The only difference is the sign. So what I'm going to do is I want to take out the negative sign from the top so that it becomes s minus 9. And obviously multiply by root s plus 3, all divided by s minus 9. This allows for us to cancel out the s minus 9, resulting in our limit of s approaching 9 to become negative square root of s plus 3, as in the whole thing. Now, we want to substitute 9 in there. The square root of 9 is 3. So 3 plus 3 is 6. And you apply the negative value. So our answer is negative 6. So here in our next problem, we're dealing with finding the limit of theta approaching negative infinity for sine theta over theta. And otherwise, from the way I'm going to tell you, I don't really have a way to solve this. But there's a simple way to solve this which doesn't require much effort, and that is squeeze theorem. And the squeeze theorem states that for three functions f of x, which is less than or equal to g of x, which is less than or equal to h of x, if the limit as x approaches some a for f of x has an equal value to the limit as x approaches that same a for h of x, then the limit as x approaches that a for g of x will also equal that same value. So we basically want to put our sine theta over theta into three functions like this, and then find these two limits to find the limit of the middle one, which is our sine theta over theta. So the way we do this is, for sine theta, it is a function that goes up and down, right? And it has a range of -1 to 1, meaning that it'll never go up above or below -1 or 1. This is why the range of sine theta is -1, is less than or equal to sine theta which is less than or equal to 1. Now you can already see that we're kind of having a resemblance to that, but these are not really functions that we want, because this isn't the function that we need. We need sine theta over theta. So what do? You divide the whole inequality by theta. So you just get 1 over theta. This is less than or equal to sine theta over theta, which is less than or equal to 1 over theta. Now all you have to do is solve for the limits of the left function and the right function to find the value for the middle function, or the sine theta over theta. So the limit as theta approaches same value, that a is negative infinity of negative 1 over theta, would be negative 1 over negative 1 over negative infinity, which is just a really some number being 1 being divided by a really big number, so just 0. And the same thing applies for normal 1 over this positive 1 over theta, which is also 0. So since these two values are the exact same, therefore these two limits are the exact same, therefore we can apply the squeeze theorem. So therefore we can state that the limit, and I'll do therefore, the limit as theta approaches negative infinity for sine theta or divided by theta is equal to 0. So our last problem is going to be psych. Thank you guys for watching. And that was all for today, folks. This was part 1 of our Calculus 1 limits, and I'm going to be covering some more techniques next time, and we might have also some limits where x, or our variable, is approaching infinity, and you're going to learn how to deal with that. And that was all for today, and thank you for watching, and I'm so happy to be back to posting YouTube and in an environment which I will enjoy. VeerMath&More, out.